I mean, like for example, the mobile application, your dApp and your light client will be the same mobile application. So the dApps make JSON RPC requests instead to Infura, it will make it to the light client, and the light client will just look for peers on the Ethereum network. So it might find one peer here that belongs to Infura, that's not a problem, but it will also find another peer that doesn't belong to Infura. And there's also another one here that it can connect to. So if one day Infura decides to just shut down, this dApp will still continue to survive. So that's the whole idea of building dApps on top of light clients. So this is the vision we have in the future, and we want to promote this vision. We want to motivate dApp developers to use more and more light clients as their backend infrastructure, and that's why we built this JavaScript library, light.js, which will just it's a simple library that you can just install from Yarn and start hacking, and you know that your dApp will work on top of light.js. So, how did it start, this light.js? So at Parity, we had this thing called Parity UI, which was like an app with a lot of dApps inside. We built around 15 or 20 dApps. And like building all this dApp, we came up with a lot of development patterns that we see constantly in our code, but also the community's code. So I'll show these patterns. I'll show 4 of the patterns. Let's say, for example, I want a tab that constantly shows my latest ERC20 token balance, whatever token it is. So the first naive solution would be to call the blockchain every 5 seconds, or every 1 second to say, okay, now give me the balance of that account. That works well, but it's quite naive. But it's still used today. For example, if you look at the MetaMask FAQ, there's one paragraph that says if you want to have the latest accounts controlled by MetaMask, you just call every 500 milliseconds on it. So it's still used today, this pattern. Well, obviously there's some problems, like for example, you make a network request, and if the request takes 10 seconds to resolve, then there may be some race conditions. So it's not the best solution. There's some more smarter polling, like let's say I call, I wait for the network response, and when I get the response, I call another, I ask another time the blockchain to give me the answer of my balance. There are some other patterns that are more with a bit more thought. Let's say so there's this thing called PubSub where you can listen to a certain channel and you get push notifications every time something happens. So it only works on some of the data on the Ethereum blockchain. So for example, it works on headers. You can listen to new headers and you say, okay, I'm pretty sure that between two blocks there's nothing happening. So I just listen to new header, and every time there's a new header, I will follow the blockchain to get my balance. And also at Parity, we also have this special PubSub on stage, where we can just PubSub on any other decent RPC. So that's also something we used internally in Parity UI that I mentioned before. So out of these patterns, some of them will work with light clients, some of them won't work with light clients. And if we select the light client friendly ones, obviously this one will be the one that will make the most sense. The other ones are not it will work, but they're not optimized enough. PubSub on stage will obviously not work on the light clients. So for light clients patterns, we're just taking this one in Parity. And that's basically the whole idea of light.js. We just look at all the patterns that are out there for dApp development. We take the best ones and we take the ones that are optimized for our light clients, and we put them into a high-level API. So, and the reason behind this is, so all these patterns are Ethereum dApp development 101, some knowledge that dApp developers are supposed to know that they should follow, but it's not in a fixed API. So the purpose of light.js is just to put this into a simple API so that they call a function, and behind the scenes, this library will choose the best pattern, will handle all the other stuff. So how does it differ when we develop that? So this is a simple example with Web3.js, which you might know. It's a JavaScript library to query the Ethereum, to talk with the Ethereum blockchain. We create a contract. We create a function that will update, that will make a call with Web3 to update the balance, and we just log the balance. And at the end, we just say, okay, I'm subscribing to the new heads, to new headers, and every time there's a new header, I will call that update balance function. So this works, and it works very well. But the thing is that developer needs to know that, yeah, okay, this should be lifetime friendly. Yeah, I'm pretty sure this is not lifetime friendly, but he should know, and future developers should also know. And the idea with Light.js is you just import this make contract function from Parity.js, from Light.js, you create your contract, you call one of the functions, and you subscribe to the results. And that's all the developer needs to know. Okay, and when he calls this function, he's absolutely sure that this will be Light client friendly, so that if this tab is on top of the Light client, it will work without any problems. So, some characteristics of Light.js, it's very simple to use. Our aim was to make it as simple as possible. So, right now, today, there's only 10 functions. You might think that it's not a lot, but we built some pretty interesting stuff with only these 10 functions. These are basically the 10 functions that most dApps use. To create the block number, to post the transaction, to interact on the contract. Light.js is reactive. So reactive programming is like a pattern or style of programming where you work with streams of data. Streams are like, if you imagine a line that represents time, you have events that happens on the stream. So like can be, your Twitter post on your Twitter feed or clicks on the button, but it also can be blocks on a blockchain. And that's why we feel like reactive programming is quite, adequate for blockchain events. So every time there's something happening, you get a push notification. So it's a push mechanism library. The structure we're using in JavaScript behind is called observables. We're using the JavaScript library called RxJS. You might know promises. Observables are known as promises on storage. You can combine them, you can filter them, you can transport them, you can do plenty of stuff with observables. And there's a huge community behind observables. So that's the pattern that we're using with Light.js. And Light.js does a lot of dirty work behind the scenes. Basically, the idea of Light.js is that since we suppose that the provider of this API is going to be a Light client, we want to make sure that the least resources are going to be used on this Light client. So, for example, like if we want to make a PubSub on a new header, we will create, this PubSub subscription, but we will also drop this PubSub subscription when we won't need the subscription anymore. Let's say you go on your tab on a page where you actually don't need the header, then Light.js will automatically drop it, and if you come back to the first page where you need the header, Light.js will create that subscription again. It handles a lot of caching. If it finds that there's this data already available, then it won't make another query. And this joins the last point. It only makes the least necessary network calls as possible, because there's latency involved, so that's something that we don't want to have. So and finally, at Parity, we use React for our UI, and so we built this Parity.js-React library that will integrate very well with Light.js. So below you just have this component that will show the balance of blah 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 is some number, and you add this something called decorator or higher order component, and this higher order component will just listen to this balance of and will put the value inside the component, and will update the component whenever the value of that balance changes, and only when it changes, not on every 5 seconds or on every 2 seconds. So Web3 Web3.js is obviously some kind of competitor to Light.js. Let me show you some of the difference we have between the two libraries. So first of all, the async management structure, primitive behind it. With Web3, you have promises, or something that they introduced recently called promise events, which is not used any elsewhere in the community. For Light.js, we have only observables. It's battle tested, used by the JavaScript community. There's some kind of internal war between those two. So we decided to go with observables. Web3.js, is it Light-client friendly? Yes, it can be, but again, it's the dev's responsibility to make it Light-client friendly. With Light.js, you're sure that it's going to be always Light-client friendly. And the decent RPC coverage, so Web3.js has 100% of the decent RPCs. Light.js doesn't want to have 100%. It focuses on simple APIs. So we have right now 10 functions. We will add more if we need or if the community needs it. But we're just building from as simple as possible. So can I use it today? Can you download and use Light.js today? The answer is yes, but we don't actually recommend to use Light clients today for production dApps. We still believe that it's not mature enough, that there's some other challenges that we'll talk about after that are not solved yet today. So if you create a dApp on top of Light client, maybe on alpha or beta version, but don't put it to production-wise. But we do recommend Light.js for every kind of dApp actually, even though you still use Infura as a backend, because after experimenting with Light.js, we found out that it works very well with remote backends like Infura. There's a similar network latency problems that we need to solve, and in particular it works well with MetaMask. So if you want to try today, just download it, create a dApp, plug it in, and you can interact with the internet network via Light.js. And the good thing is, if one day, if our vision of embedding Light.js everywhere works, then if you want to switch to a Light client, when they become more stable, then you won't have to change a single line of code in your code base. That's some experience that we went through when we had this old Parity UI. We tried to run it on top of Light client, half of the dApps didn't work because we didn't have that library. With this Light.js, we will be sure that it will work. So if you want to get started with Light.js, go to this website is it's like a documentation page where you have tutorials, how to get started, some guides and some concepts of Light.js, and the full API. So everything is documented, everything is in TypeScript, you have types. There's a lot of examples, etc., etc. And of course, the code is open source. So we cannot see here, but there's a GitHub link over there. The code is open source under the MIT license, so you can use it from today. Next step is Light clients. So that was Light.js, but we want to do more stuff on top of Light clients. Our goal, like I said, was to embed Light clients everywhere, which actually will facilitate the Ethereum mass adoption, particularly in mobile phones, etc., while maintaining the centralization. But of course, it comes with challenges. So the scope of the talk today is not to talk about these challenges, but I need to mention because it's quite important. The biggest challenge is how to incentivize phone nodes to serve Light clients, because right now Light clients are only leeching on the network. They're not in any way helping the network. So they are asking for free data on the network and they're receiving them. So we need some incentivization layer on top of Light clients, to control that. At Parity, we started something called the Parity Light protocol, which is based on a credit system. Light clients will have credits, and if they ask for some requests, the credits will go up and will slowly fill up with time. With this way, we can control that the Light clients don't spam the phone nodes. There are other things like Dnode, VIP node working also on phone nodes incentivization. So this is a big problem that needs to be solved before Lightning become mainstream. On the side, we will of course also promote people to start thinking about building that on top of Light's clients. So to improve Light.js, in particular, we want to add more functions. We want to add some prioritization of network calls because some of them are more expensive, like they use more credit typically than other calls. So we want to prioritize inside of Light.js to tell the developer somehow that, okay, maybe this call should be made before the other one, etc. Want to make it more configurable so that the developer can choose which calls, he finds are more important than others, so that there's some parity of functions to use, etc., etc. And to show you the power of Light.js, we built actually a full Ethereum and ERC20 token wallets on top of Light.js and on top of the Light client, and it works very well. So it uses Light.js, it's bundled with Parity Ethereum, which will be run with the --Light, so only the Light client will run. It syncs in 45 seconds, so that's really cool. It's a desktop application. It has only 3 screens, so a very simple UX. And the alpha version will be released next week. We still have some raw patches to fix. Wanted to for the Devcon not in the Devcon trace, but wait a bit. So next week, if you follow the blog, if you follow Parity's Twitter account, you will see that this Feather application will be released next week. But today, if you want, you just go on this GitHub, Parity.tech/Feather, and you can download the binary, you can see the source code, you can build it yourself. So basically, we cannot see much here. So it's just 3 screens. First screen, here's the list of accounts that you manage in your wallet. Second screen, for each account, the tokens and your Ethereum balance. You can add a whitelist of tokens over here. And third screen is to send Ethereum or send Ether or send any tokens. So super simple UX. We didn't want to do anything complicated. We're actually not that good at UX at Parity, so it's not we just want to build a proof of concept. But the most important thing is it's working. Light.js is used. You can build that today with Light.js, but as I said, it's not expert, it's not production ready, so we're releasing as an alpha, and we're only releasing on the Poland testnet. And we have a feature to embed Feather a bit everywhere. First of all, our next target would be Android. We already managed to run Parity Ethereum Light client inside an Android app to make an RPT request and to receive the response in the Android app. So that's that's 90% of the work done on the Light client. We don't actually, unfortunately, have enough resources to work on it, so it's not being actively maintained. In the further future, we want to have Feather as a browser extension, something like MetaMask, but instead of MetaMask connecting to a backend, we would compile Parity Ethereum, the Light client, to WASM so that it can run inside the browser with almost native performance. And this Chrome extension will just connect to that sprouting Light client inside your browser, and your browser will be Light nodes in the network. And in the long term is to have Feather as a website, that will be the holy grail, to just type feather.parity.io will sync in 45 seconds or hopefully less, 10-15 seconds, and you can have this website as the website is a Light node in the network. So if you're also interested to add the Light client inside your project, come talk to us because we would be very happy to work with you on that. Thank you very much. You can find me, Amaury Martini, in this. You can also have the documentation. So thank you for listening to my talk.
We actually have time for questions? You think so? Let's do 1 or 2 questions. Does anyone have a question? Give me a second. Oh, what's your question?
the question is how many wallets are going to support Parity Light clients in the future. Currently none of the wallets are supporting, but we are actually working with some of the most popular wallets for them to at least try the Light clients as as one of the potential providers to have. So I won't say any names, but there are some wallets interested in having a Light client as a possible form provider.
Do you have a question? Do you have a question? All right. Maybe you could also just shout it out. I think
okay, so am I correct to assume it requires WebSocket connections? If so, Kovan Infura doesn't support you with WebSocket.
So Infura does support the...
Repeat the question.
But not for Kovan.
I'll repeat the question. So the question is if we do some pub stuff, we obviously need a WebSocket connection for the subscription. However, Infura doesn't support pub stuff for Kovan. So yeah, how do we solve that? So the answer is right now on Kovan, right? So the answer is on the iPad, there's some intelligent thing that says if PubSub is supported, then I will use PubSub. If it's not supported, then I will just query every, I think 1 second right now it's configured. Yeah, so that's I mentioned we want to make it more configurable. That's part of the making more configurable. Right now it's hard coded, but shouldn't be that hard to add some, config somewhere.
also there will be a break, and maybe you can talk to her more. Okay, thanks a lot. Good job. I hope I'm saying that right. We're talking about P2P tech for robotics. After this talk, there is a short break, so if you guys have more questions, there's a lot of people to
Good day everyone. My name is Evgeny Shukov. I'm software architect and project with name Urbanovix platform, and today I will give you a short introduction in basic ideas behind Urbanovix platform, and after I will show you demonstration of using IPFS and Ethereum protocol with robotics in concept of smart cities. So first, okay. Yeah, okay. First of from robotics side, we use ROS. ROS is a robot operating system framework. It's open source framework, and as I know, it's the most popular framework for robotics today. And in Urbanovix platform, we build bridge between ROS and IPFS and Ethereum protocols. But why we do that? Why it can be interesting to using protocols like Ethereum for robotics? And one of the answers what we have to this question is Bitcoin, for example, it's not only first global financial institution. For us, Bitcoin is the first money for robots, because before Bitcoin you cannot go to bank and say, hey guys, here's my robot, can you open bank account for him? But in cryptocurrency today, humans and machines can own funds without third party. So second idea is about smart contracts as a contracts for robots, because with smart contracts we can create direct economical communications between humans and machines to machines. Because in smart contracts we can combine technical and economical details into one transaction. And with this idea we can build some projects in smart cities and Industry 4 concepts. And now I will show you one demonstration where we use from human side decentralized application with IPFS and MetaMask support, and we connect 5 different sensors with the Parity client to Robonomics network. And here's what we have. When I push button broadcast signal, I sign message with my external owned account for Ethereum network. And some sensors send me back IPFS hash with data, but part of the sensors send me back not a data, but they give me opportunity to create smart contract with them. And only after smart contract will be created, these sensors will start their work and collect data, push it in IPFS, and send transaction to Ethereum. Demonstration, what we can find. We can imagine 3 types of communications. We can build open sensors network in smart cities. We can create access control list systems in smart city. And last one, IoT data marketplace with payments inside. And what is interesting? Peer-to-peer technology gives us opportunity to build such sensors network with zero cost for infrastructure. In this demonstration, we don't have a backend or central server which will control access control list. Our communication here between decentralized application, publisher-subscriber pattern, and direct sensors in system. So, if you're interested to connect your robotics project, if you're interested to use Parity and ROS, you can find our repository in GitHub in Robonomics platform by Aerolab. And if you have any question, you can ask me here. I am here. So, thank you.
Cool, so we're going to take 15 minutes to mingle and chat if you guys have more questions. And after this, we're coming back and talk about Polkadot and Substrate, which is real. So we hope you'll stick around. Cool, mingle. And to the people in the back, I know you can't hear me, but please come forward. I'll just gesture your way. For people who can hear me, can you tell the people behind you to sort of move up? Is that cool? I see you. Yeah, help me. Okay. Nice. All right, so we have some really exciting talks coming up. Actually, it's still really noisy, so maybe I'll wait a second. Hey, everybody! Can you guys come up? Maybe you guys can help me bring some people over. Come on! Hey, Rob! Come on. But you're on this team. Okay, so I want to introduce the next speaker. He is an up-and-comer on Twitter. Everyone can follow Fabian on Twitter. He's really good. And yeah, he's going to be talking about Polkadot and Substrate. So if you're curious about this, please join and listen. Welcome, Fabi. Give him a hand.
Thanks, Anna, for the intro. Yeah, follow me on Twitter, that's my handle. If you can't read it, it's Fabian Chido MPF. It's quality content 24/7. You want to credit. I want to use the next 20 to 30 minutes to give a bit of a Parity, like untypical talk, in the sense that I don't want to talk about tech and what we build and how the inside looks. I think we've done it quite a bit over the last weeks and months in the context of Substrate and Polkadot. I rather want to talk about intentions. So why do we get up every morning in Parity, and why do we build exactly those two things, not something different? And I want to basically make two cases and kind of like outline the trends we see right now in the space. And lost my signal. Yeah, so I want to talk a little bit about the trends we see in the space, and kind of want to make four cases and talk a little bit about how this maps into the technology stack we have and the design decisions we make. So in particular, it's four cases. Like one, and they're kind of like building up, like building onto each other. So one is a case for like further diversification and specialization in blockchain technology. If you believe that there should be more specialized blockchains and more diversification, I think it's also easy to make a case that we should probably not start from scratch all the time. We should probably think about standardization, like reusing working tech, and kind of like coming up with building blocks to build those chains. So this is all what we're doing with Substrate. The other thing is Polkadot. So if you believe in a world where we should have all those different chains and we can actually build them easily and in a secure way, then I think it's also not so hard to understand that we want blockchain interoperability. We want some way for blockchain networks to be able to talk to each other and understand each other. And the fourth point is, and it's probably the least talked about, is if we have all that, we have all those different chains and they all talk to each other, then we also want to pool their security. That makes sense without interoperability, but it makes especially sense in the context of interoperability. All right, so before that, I want to talk a little bit about Substrate and Polkadot, just so we're all on the same page what that even is. So who here has heard of Polkadot and like thinks he has a rough understanding of what the capabilities are? Awesome. What about Substrate? Oh, that's pretty good. Okay, we can almost skip the next slide. I still want to untangle a little bit like some misconceptions that are going around, maybe also because of poor communication from our side, I don't know. So Polkadot is a like a protocol we're working on in concert with the Web3 Foundation. It's really an open interoperability and pool security protocol. Substrate is a development framework. It's a software framework to build blockchain technologies from the ground up. It is much more of a kind of like Parity Technologies product in that sense. The relationship you can see here, I'm not sure how good you can actually see it, but it's like a Venn diagram. You have in the middle, you can build Polkadot parachains on Substrate, but you can also build Substrate chains that are not integrated into Polkadot, and you can build parachains on Polkadot that are not built on Substrate. But the two technologies just make a ton of sense together and are pretty powerful together. So those are kind of like the different ways of integrating substrate-based chains. In Polkadot, on the very left, you see no integration, what's called solo chain here. It's basically a chain that's completely sovereign, it has its own consensus, and it just lives on its own. Bridge chains, Jutta was already mentioning that. Björn is going to give on Friday, I think, on the main stage at Devcon, a whole talk about the Parity Bridge. It's going to be the technology that on the basis of this is going to work on, but it's still, you're completely sovereign with your chain. You don't get the pool security part of Polkadot, but you get the interoperability part. And parachain is where you basically, you're still sovereign over the state transition, but you give up the consensus and you plug into the Polkadot consensus. Okay, so now I want to start making my cases. It's a little bit unfortunate that we can't see that at all. It's basically like 3 steps back. It's the idea of how specialization and generalization usually stand in tension, and that's like all over engineering, right? You can, like, you know that like from software programming, like from object-oriented programming, we talk a lot about that, but really that's true all over engineering. Like if you think about like actual physical tools, like for builders, like you can have a tool that's really specialized, that works for like one use case very well and is optimized for that, or you can have a tool that works on a lot of use cases, but just not as good, right? It's much more flexible. And if you look at the blockchain protocol engineering, I would argue we have right now like an engineering bias towards generalization. We see most projects want to build platforms. They want to build platforms like smart contract platforms where you have like, you want to have a DEX, you want to have a stablecoin, you want to be a currency, you want to have like, governance figured out. In the end, you want to make use of those networks effects and go like all the way flexible, and but not actually optimizing for anything in specific. So the most extreme case for optimizing in like a blockchain case would be something like a completely application-specific blockchain. And there are tons of reasons why you would like to do that. Like there are performance reasons where like maybe your VM is actually a bottleneck, and you're not in an app-specific chain. You can like actually have like a single app optimized state machine. There's security reasons where due to the complexity of the VM, you have a pretty big, like a pretty broad attack vector. There are reasons for like having a very sovereign chain. Like if you think about Ethereum, you're bound to Ethereum governance, so you're bound to what kind of VIPs core devs push forward, or you're dependent on what kind of research roadmap the Ethereum Foundation comes up with. If you build your DApp on that. And flexibility feeds into the same thing. You're bound to the general platform limitations. Obviously, if you have your own chain, you can much more customize that. So why is basically no one doing that? There are pretty much 2 reasons. One is network effects. And network effects is like, if you think about something like 0x or MakerDAO, there's tons of these like lower level building blocks on the Ethereum blockchain that like a lot of app developers can leverage. If you would have your own chain, you would need to build all that from scratch. You can't plug into the data, the identity, all that stuff that's there. Obviously, if you have interoperability solutions, that's like it's not a silver bullet for that, but it definitely mitigates that quite a bit. I think there's still a place for platforms, simply because interoperability comes at a cost, like whether that's like latency or cross-chain transaction costs or something like that. There will always be platforms, but we can mitigate it to a very large degree with proper interoperability network. And the second thing is engineering effort. So it's pretty hard to build a blockchain from scratch. God damn it. Nice. Yeah, it's pretty hard to build a blockchain from scratch. Like we see that, there are tons of examples when you talk about kind of like cryptographic vulnerabilities in IOTA or like broken BFT consensus in EOS or NEO. Wrong usage of cryptography, let's put it that way. In this, the list goes on and on. It's like because people reinvent the wheel all the time. Like they reinvent the wheel over and over again. So our approach with Substrate is, can we not come up with a rock solid basis, a substrate of peer-to-peer networking and pluggable consensus, and then on top of that, kind of like everything that's unique to the chain, everything that's part of the state machine, put into like modules and libraries so they can either write your own or like plug them together to actually have a unique chain. This is how we want to break out of the problem that we often have with software frameworks where either it's like too flexible and you don't even know where to start, or it's too restrictive and you can't actually build what you want to build. So we've started to build a bunch of things on Substrate ourselves to like showcase and test how flexible this framework actually is. So one thing is a WASM-based smart contract platform. So this is a screenshot from a monitoring service we have. If you go on telemetry.polkadot.io, you can check it out. It's a live test network of that we built on top of Substrate. Another thing is, and Git was already mentioned that Rob is actually going to talk about that on Friday at Devcon, is we've started a prototype, or built a prototype of the Shasper beacon chain on top of Substrate. We're also playing around with kind of like the Bitcoin UTXO model, and like you can go as far as not being bound to the actual data structure of blockchain. So we are playing or experimenting with building more of a DAG-like system on top of Substrate. Another thing we're building on Substrate, and now it gets a little bit meta, is Polkadot itself. So the relay chain of Polkadot is also being built with Substrate. This is again a screenshot of the monitoring service. You can use the same service because it has the same basis of Substrate, so the interfaces look the same. Again, we have a live test network that you can check out. So this was the Substrate part of things. So now that we've established if those things actually work, and we can people can easily build secure blockchains, and we have a world with a lot of different chains that fulfill their niche and have their place in the ecosystem. Then really what we want those chains to be able to talk to each other. And this is why why we came up with Polkadot, why we spend so much time with Polkadot. This is not really Polkadot how it looks now. It's more of a Polkadot vision, or how we imagine maybe Polkadot to be 2 or 3 years from now. You see in the very left, if you see anything, I don't know. It's a WASM-based, what I was talking about, a WASM-based smart contract platform on Substrate. You see like the bridge to Ethereum 1.0. You see here a ZKH parachain like it has had, which just announced like a few hours ago. The cooperation with the ZKH Foundation to build the first one Zcash company, Zcash implementation. And you see here kind of like a layer down where you have where the relay chain has another relay chain as a parent chain, and you get these like nested relay chains, and you end up with this tree structure of blockchains. And on the very bottom, you see like kind of like an energy-specific relay chain that has a bunch of like industry-specific chains. This feeds into what I was saying, that interoperability might actually be expensive, so you want to make sure like locally chains are close to each other, that they communicate often to each other. Okay, so we're missing the last part of pool security. So even if you're not talking about interoperability, securing a blockchain is pretty hard. So again, those are just a bunch of headlines of chains that are like 51% attacked, usually like double spends against exchanges or something like that. So this already happens quite frequently. And I'm sure like most people know that website. There's a great website called crypto51.app. It basically lists like the cost to 51% attack a bunch of proof of work coins for 1 hour. And what you realize if you look at that, it's pretty damn cheap to do that. It's like surprisingly cheap. And that's due to the fact that like every time you spin up a new chain, you compete over the hashing power that is out there in the world. And if you believe in a world where we have lots of different chains and this diversification keeps going, then this will get worse and worse, right? We will have more and more chains that compete over these resources. That's not just true for proof of work, it's also true for proof of stake. There's just so many people who are willing to put down like value to be validators of those chains. Now, if we talk about interoperability, it gets pretty interesting because if we have, I think it's best explained with like a simple example. If you have two chains that are interoperable with each other, so let's say there's just like a simple bridge deployed, and you can make a token transfer from like a less secure chain to a more secure chain, and the less secure chain, the transaction gets rewarded. There's like an attack or whatever, the cost of the transaction got rewarded, but the effect of this transaction, meaning like someone has more balance in their account, actually just moved on, and you run into inconsistencies. Like this is already pretty bad if you have like two chains, right? Like imagine having like a network of like hundreds of chains being interoperable, and you only connect them with those bridges. It gets messy pretty quickly. So really what you want to have is a network where they can all pool their security and like they all share the same security guarantees. Yeah, so where are we with all those things now? So with Substrate, we're like 10 or 11 months into the project. We're a few weeks out away from the first kind of like beta release. So all the stuff is already open source, you can check it out. We already have the first teams who like start hacking on Substrate and start building stuff. But with this beta release, this will come with like much improved kind of like developer experience and documentation in general. Polkadot, and we want to do like a 1.0 release of Substrate at some point beginning of next year. Polkadot, obviously, since it's built on Substrate, it's a bit further out. Polkadot, we want to go live in like end of summer next year, roughly. So this was all pretty high level. If you want to dig deeper, there was the Web3 Summit last week in Berlin. There's a great talk by Gav. It's like half of a kind of like coding demo, half, I don't know, circus performance or something like that. It's definitely worth watching. It's basically him bashing on his keyboard and like demoing how to build on Substrate. There's also another like I think 2.5 workshop or something like that where Gav does like a whole kind of code level deep dive into Substrate. So if you wanna get deeper, that's definitely worth checking out. Thanks.
Does anyone have any questions about second. I know it takes a while sometimes. Any questions? Do you have a question for yourself?
No, I just want to say, like, there are a bunch of like Polkadot and Substrate, like core devs here also. Just like come find us and talk to us.
Cool. Oh,
And we're hiring. Parity.io/jobs. Check it out.
thank you. All right. So next up, we have Antoine Majorin. He's going to speak really briefly about Speckle OS. There you are. Hey, cool. Welcome. Go ahead. You got it.
Hey everyone, I'm Anton. I'm working on a community project for Polkadot called Speckle OS. And to give the quick spiel on what Speckle OS is, it's essentially the UX layer on top of the Polkadot network, whereby different substrate chains and parachains connected to Polkadot can be used by the user into a unified experience. A separate part of that would be also developing a highly configurable UI through which other substrate chains not connected to Polkadot would be easily be able to deploy for their user base on Substrate quite quickly. In addition to that, we're also looking at allowing connecting different protocols across the Polkadot network to allow the user to have a unified experience in terms of decentralized identity and other core components to the user experience. Thank you.
All right, so this is our last talk of the evening. Emil Sebastian is going to be talking about Polkascan. We'll just give him 1 second to set up. This is another community project. It's kind of exciting.
Thank you all, and nice of you to be here. I'm glad to see so many people here. I'm with the Polkascan project. It's basically a block explorer for Polkadot, or a generalized substrate block explorer. Any chain basically needs a block explorer, so that's what we're building. This is me. I'm Dutch. I'm from Rotterdam. That's my Twitter handle. Entrepreneur, researcher, engineer. I'm a meetup organizer in the Netherlands. I'm a co-organizer of the Ethereum meetups, and I organize the Polkadot and our meetup. And I'm working on 2 projects at the moment: Web3 Scan and Web3 Source. This will focus on Web3 Scan, which deals with block explorers, and I love Ethereum and the culture especially. So, what do we do? It is a personal interest of me that you have all these block chains, and then you get into the trouble that you want to stuff out of it, and it's kind of difficult. So there's some stuff you can get out easy, and there's some stuff that's way harder to get out, and that's where it gets interesting, and that's where block explorers, in my opinion, play a role. So stuff that's easy, that's single transactions or transactions by block, that sort of stuff that is indexed, but we already know, and we heard that light clients offer less data, archive nodes offer more data, and you have all sorts of tricky stuff to get that running. So that's stuff you get from one node, but sometimes you want stuff from multiple blockchains or multiple nodes. There's stuff you want to from stuff that's outside of the blockchain, so you want to correlate it with that. So it's pretty difficult. So all these associations, when you get into semantics, it's pretty hard. So what we try to do is focus on everything that's not easy to get out of one single node. Yeah. So we want to make multi-chain data accessible and understandable. So there's a direction I think we are heading in multi-chain reality. I think most people would agree now, and I guess there will be multi-chain applications as well. So apps or applications that rely on data that comes from multiple chains. And there's this trend in Explorers. You know, there's a Telegram. Yeah, it's a Telegram channel. I'm participating in. It's the Open Block Explorers Now channel. It's moderated by Griff Green, and we've had quite vivid discussions on that, on how to actually build these substitutes for Etherscan, which we have come to rely on very heavily. Well, and there's some usability improvements, I guess, with Block Explorers. So one interesting question is, how do you design an Explorer for a multi-chain reality? There's lots to do there. So we do focus on Polkadot and Substrate. Why, you may ask? Basically, it allows us to, you know, lockstep with the developers of Substrate and to position this product well in the upcoming 12 months in which Parity is developing it. So perhaps it is nice to say that I did build an EVM Explorer, but it's really hard to position such a system, and it's really expensive to operate a high storage and high traffic website such as Etherscan. So you need to have really deep pockets or a good business model to run such a business. So how do we build our block explorers? Basic architecture, you have all these sources and you have all these applications, and there's a gap in between. So many applications don't simply run on top of a node. There's all sorts of work with the light clients, as we've heard, but then there are applications that simply won't run on a light client. So it's an interesting piece in between. So I guess you could name it middleware, but you could name anything middleware that is in between, but we don't want to get too fixated on what it exactly means. So what do we do? There is Substrate nodes or Ethereum nodes for the Ethereum block explorers we built. We have a very thin application that just harvests all the RPC data from the node. We put it in a relational database, and we index it, associate it, enrich it, and so on. And then there is a very thin provisioning layer on top of very tailored databases for example, an Explorer, JSON API layer, which services the Explorer GUI. This may not be the best, it may not be the most performant solution, but it is a very flexible solution. You know, we don't know in what direction or what these future applications will be, but this allows us to anticipate for as broad scenarios as possible. So in the future, we may actually get many more sources. We may go to more performant type of storage, graph databases, NoSQL databases, less centralized types of storage like IPFS, and we can have many more interfaces on top. But that's not something for now, it's something for later. So what we want to do is be very pragmatic and be able to serve those block explorers today. And this is the way to go, in our opinion. So in 5 sheets, I'll show you how we go from a node to an application. The beamer sucks, so you have to do with my story. This is a Dockerized node. So basically, if you can run a node in Docker, this is what it is. It services RPCs. This is a Postman screen dump, and it shows a request and a response. So we do the requests for every sequential block and some other requests maybe, and we get a response, we put it in a database, and then we start using stored procedures, which is in a MySQL DBMS, and we normalize all the data in a very raw and flexible format, and then we put it into some targeted databases. So the raw database is something that gives us flexibility, and the targeted Explorer database is something that works well for the Explorer application. And there is a JSON API layer on top of it. It's really, really simple and straightforward, and that gets us to the user interface. And again, is a bit unfortunate. So Polkadot is a multi-chain user interface. It has, at the moment, two networks, two testnets, which are both substrate instances. So there is the relay chain. We use color codings to differentiate the chains. The relay chain is pink, and the WASM smart contract platform testnet, barbecue birch it's called, it's green. And currently you can go into the Explorer towards that section. But there will be all sorts of interoperability, and it's interesting once these networks mature, how we can get that cross-chain communication in this same user interface. So that's the real design challenge we're facing at some point. So this is the pink chain, so this is the relay chain. Pink comes from the original Polkadot logo, which has a pink dot. It shows some basic information. It has a menu with activity, agents, and analysis, and some more nowadays. This is the smart contract platform. The relay chain will be reset next week or the week after, and it will start from scratch because it will have some new version and some new features. So we've made some of the recent advances in the barbecue birch relay chain. So it has a block overview page. Basically, it shows the blocks with a detailed page and a number of attributes. It shows, it's unfortunate, but it shows the details. It shows extrinsics. This is something I need to explain. So in Polkadot or in Substrate, we all know what transactions are. Extrinsics are a bit of an abstraction of transactions. So that's basically what you all need to know, but there's different types of transactions, and I'm not going to explain this. It's complicated, but what is important is that Substrate is a framework that allows you to build any type of blockchain on top. So, and Polkadot is one such instance. And Barbecue Birch, the smart contract platform, is another instance. So they both have the same code base underneath, which is Substrate, and the only thing in which they differ is the runtime. And my goal at explaining that Substrate is the generalized hardware, and the runtime is the firmware that makes one piece of hardware different from another piece of hardware. So the thing is with the runtime, that the runtime describes which methods, which calls, which events are available within the blockchain. So in addition to that runtime with all these features, there is also a descriptive part of the runtime, which is called the metadata. And the metadata is the full description of what makes the runtime. So how you have to decode, for example, these extrinsics. So one chain, the relay chain, would have a transfer function, for example, to allow you to transfer dots from one account to another account. But that's not part of Substrate itself, it's part of the runtime. So another chain might not have such a transfer function, or might not even have a native token. So that's interesting. So the first thing we actually did in order to build the fully generalized Substrate block explorer is to build a runtime explorer. So by exploring the runtime, it allows us to decode what features are actually available within the blockchain itself. So eventually, we will provide turnkey solutions for any organization building their new Polkadot, their new substrate instance. So graphics are bad, so I'm going to skip this part. You can check this out at polkadot.io. So blocks are not yet updating in real time. We will work on that once the new release of the relay chain is out. So what do we plan to do? Working on that real-time data feed. Work on all these runtime features. So currently it's really general. We do blocks and extrinsics and some of the accounts, but you really want to get into all that stuff that the runtime says that the chain offers. Like token balances, balance history. If you look at the proof of stake mechanism, when did your balance accrue because of the staking reward, and when did you get slashed? All that sort of historical information. That's really interesting to see, and that's what differentiates this block explorer from all the other user interfaces that have been available so far for Substrate. If you have that information in a database, it's really straightforward to build some indexes on that, so you can filter and search on particular things. Anyone using Etherscan kind of can come up with some straightforward examples of what you would want to search for. We'll be Dockerizing and open sourcing the Explorer GUI. We'll start issue tracking and accepting requests. And on the midterm, we will be opening up an API, so you can build on top of that. That's important too. What we do want to do is reach out to the community. So we would really like to get in touch with all the parties and organizations that are actually building on Substrate or intend to build on Substrate, because I think it is really good for us and for them to be in close touch to help us prioritize on what features we should develop. We want to partner with complementary service providers, so we've already had some discussions with people with other database management systems that are more performant. There's some synergy in that. If you can convince us, you can contribute to our services, come talk to us, we might even hire you. And there's room for building open source components. My web development skills are a bit old, so I use Symfony framework and it's PHP and stuff, and there's all sorts of sexy stuff that could improve the user interface with the reactive components, the single page applications, and all the names I don't have because I can't build it. So reach out if you want to contribute to that. And we are, of course, always open to suggestions. Yeah, that's it for now. Thank you.
Everybody, so despite some projection problems and despite sometimes the sound not being amazing, there were some very good presentations here and some cool projects that I think are worth checking out. So where can they find you?
Polkadot.io.
So check these guys out. And I was told to shamelessly plug my podcast again in case somebody didn't hear what it was. It's called Zero Knowledge. It's myself and Frederick, who's the CTO of Parity. We do it every week. Please check it out. And we have, I think, about an hour in this space. So please feel free to meet each other, chat, hang out. And yeah, thanks everyone for coming. Cheers.